Today we will discuss about condensation polymerization reaction. So already you are well familiar with addition polymerization reactions where the monomers are added successively to get a macromolecule. Is it? So here it is the condensation polymerization. It is a process in which two or more different bifunctional monomers are subjected to condensation reaction, during which there is an elimination of simple molecules like H2O, HCl, NH3, etc. to give a macromolecule or a polymer. It is said to be a condensation polymerization. So in condensation polymerization, two different bifunctional monomers undergo condensation reaction with the elimination of simple molecules to give a macromolecule is said to be a condensation polymerization. So for your studies, see they have mentioned nylon 6,6. Say it is a polyamide. It is an example for polyamide. So during the preparation or polymerization of nylon 6,6, two monomers which are different monomers having two functional groups. Say adipic acid, there are two COOH group, and hexamethylene diamine, there are two NH2 group. When these two molecules subjected to condensation, so there is a elimination of water molecule. There is an elimination of water molecule. Say here 1H. So this will be eliminated in the form of this H plus OH minus will be eliminated in the form of H2O, and which results in the formation of linkage, that is amide linkage, CONH bond. And say as a result of condensation of these two monomers, a polymer is obtained, and this is nothing but nylon 6,6, or it is a partial structure of nylon 6,6. Okay, so here the monomers are adipic acid and hexamethylene diamide. So the preparation of monomers is to be studied. Okay, say the starting material, that is 1,3-butadiene is taken. So it is a 1,3-butadiene. When it is subjected to chlorination, it undergoes a 1,4 substitution reaction, so thereby giving dichlorobutene. Okay, 1,4 dichlorobutene is formed, and when it is treated with sodium cyanide, dicyano, that means 1,3-dicyano butene is obtained. Butene is obtained. Okay, and further, when this one is subjected to reduction, that means in presence of nickel as a catalyst, when it undergoes reduction reaction, it gives 1,4-dicyano-butane. It gives 1,4-dicyano-butane. So further, there are two different procedures or reactions. In one reaction, when this molecule is subjected to acid hydrolysis, it gives adipic acid, and when this molecule is subjected to reduction once again by using lithium aluminum hydride, say it gives hexamethylene diamide. Okay, in this way, starting from the 1,3-butadiene, first step is chlorination, then it is treated with sodium cyanide, and further it is subjected to reduction, and you will get the alkene molecule, that means dicyano butene. And when this molecule it is subjected to hydrolysis, you will get adipic acid, and when it is subjected to reduction, so it gives hexamethylene diamide. Okay, so now the properties of say polymer, that means nylon 6,6, it is quite tough. It is having high toughness, having high strength, and also elasticity, very good elasticity, and it is a non-conductor of electricity. It's a very good insulator, and which is having thermal resistance and abrasion, etc. So it is they are waterproof, or say they are fiber like nylon 66 is a fiber like crystalline material, and it is resistant to acids and also to the atmospheric constitutions or constituents. Say with this, the nylon, it is used mainly in textile industries and also in mechanical industries. That means during the preparation of parts of automobiles, so like gear, bearings, tire, and also in the preparation of ropes, and say based on it, and even in the electrical devices they are used because they are good, say, insulators. So with this, we'll move on to the next one, that is differences between say cationic and anionic polymerization. So already in previous class we have studied about say cationic polymerization and anionic polymerization, is it? So based on the factors, so we can differentiate these two. The first one is in cationic polymerization, say carbonium ion is the chain propagator, and here it is carb anion is the chain propagator. So the second one we can say in carbonium ion, the positive group or say positive charge is the active sites. It is a active site, and which leads to the lengthening or chain carrier, which acts as a chain carrier. So in this case, the active center or the active site is the negative charge of the carb anion, and which leads or which carries the chain propagation, or it propagates the chain. Okay, so the third point is you have seen, so usually they are the alkene, say with R group. Okay, so in this case R group is, say it is a electron donating group. So in case of cationic, it is an electron donating group. So thereby what happens? The shifting of electron takes place, and electrophile, that is the initiator, so this attacks the monomer. So it is a monomer, and where R is electron donating group, but in this case R is electron withdrawing group. So electron will shift like this, and here the initiator is a nucleophile, and which attacks the carbon of the double bond, is it? So in cationic, R is electron donating group, where here R is electron withdrawing group. So where R is electron withdrawing group, is it? See, thereby the shifting of pi electrons, it is from right to left in cationic polymerization, here from nucleophilic, that means initiator, to the monomer. Okay, therefore the shifting is in the direction of propagation of chain propagation, and here it is the direction of say shifting of electron is opposite to the direction of the propagation of the chain. Okay, so now the fourth point here, see the presence of electron donating group, it stabilizes the positive charge on the carbonium ion, and here electron withdrawing group, which stabilizes, see, the negative charge on the carbonium ion. Okay, so now we can see here rate of, see, polymerization. So in case of cationic polymerization, usually it is fast at low temperature. It is usually fast at low temperature. As the temperature decreases, rate of polymerization increases. But here the rate of polymerization increases with increase in temperature. See here, rate of polymerization increases with increase. At room temperature itself it is fast, and as the temperature increases, the rate of polymerization is also increases. And already you have seen, actually here the Lewis acids are the initiators, is it? Initiators, or which acts as a electrophile, and here either Lewis bases or organic, say, compounds, organometallic compounds or organo, say, metals, they are acting as a initiators. They are acting as a initiators, or they act as a nucleophile. They are attacking as a nucleophile, is it? So examples already you are familiar. Here it is polybutadiene or polyethylene or polypropylene, isn't it? See, polyisobutene. So these are the example, and even the styrene, which is an exception. So polystyrene. Polystyrene is an example for cationic polymerization. So in this case, see PVC, polyvinyl chloride, or see PAMA or polystyrene. Even the polystyrene is also an example under anionic polymerization. So you are already well familiar with these examples, is it? So with this we'll move on to the next one, that is, see the differences between condensation polymerization and addition polymerization. Addition polymerization and condensation polymerization. So here we can give the certain points based on the factors or the say rules and conditions of the reactions. Okay, the first one is, say, the unsaturated monomers are undergoing, say, unsaturated monomers are giving polymers, is it? But here there is a single monomer, okay, which gives a macromolecules, that is Mn. But here two monomers are combined, and which are bifunctional, okay. Monomers are combined to give a macromolecule or a polymer, okay. So there are elimination of, say, simple molecules like H2O, HCl, is it, CO2 or NH3, etc. So there is an elimination of such simple molecules. So but here there is no elimination of simple molecules, okay. Now we'll go to the second point. See, in the here it is said to be a chain growth polymerization. This is said to be a chain growth polymerization, but it is said to be a step growth. It is said to be a step growth. So the third point is, it is non-biodegradable. It is non-biodegradable, but here it is biodegradable. So which is eco-friendly, biodegradable. Okay, the condensation polymers are eco-friendly, which are degradable, and where here they are non-biodegradable. And the fourth point is, here usually the initiators attack the monomer across the double bond. So they attack across the double bond, but here there is no such situation. So the addition polymerization where the monomers are continuously added, therefore the empirical formula. So empirical formula remains the same. It is same throughout. Okay, say empirical formula, but here it is different. Empirical formula is different. Okay, and these are resistance to acid. So they are acid resistance, or say we can say they are resistance to acid, but here easily hydrolyzed by acid. They hydrolyzed by acid because they are polar in nature. So usually these condensation polymers are polar in nature. So here the reaction is, this polymerization reaction is fast and polymer is given at once, but here it is a slow process. It is a slow process, and here we can give the example, say nylon 6 or nylon 66 or bakelite, etc. And here there are many examples, polyethylene, polystyrene. Okay, so PVC, is it, etc. Say polystyrene and Parma. So these are the examples under addition polymerization. So with this we'll discuss in the next class. Thank you.